Equations and units practice number 1. Now, when you're going through this, right, this is going to be the start of each one of these, right, you need to follow these steps, right, so if I was you, I'd just kind of make a note of them somewhere. Number 1, extract the data from the question. Number 2, choose a formula. Number 3, check and convert your units. Number 4, substitute the numbers in, right, so you put them into the right place. Solve the equation. Round to whatever they're asking you to, decimal places or significant figures, and then make sure that you add in the correct unit. Follow those 7 steps every single time in a physics question if there's numbers involved. Right, first question. When a skydiver with a mass of 60 kilograms, right, so what I'm going to do here is I'm going to think about those steps that I just talked about. Extracting the data. So I've got 60 kilograms, which is a mass. I've got 10,000 meters, and the gravitational field strength of 9.8 newtons per kilogram. What is the skydiver's gravitational potential energy? So what I do is I go to my equation sheet and I find the equation that's got all 4 of those things in. And the equation is, now I might have to not write them out fully here, but in your exam you write them out fully. So it is gravitational potential energy equals mass times gravitational field strength times height. Units of each one, gravitational potential is joules, mass, kilograms, gravitational field strength, newtons per kilogram, height, meters. Now, what I do is I substitute in. Substitute in my numbers, 60 kilograms. Gravitational field strength is 9.8. Multiplied by the height is 10,000. That is then my gravitational potential energy, okay, which is often written as EP. 60 times 9.5 times 10,000 is 588,000 joules. Okay, and it doesn't say to do anything else other than that. What is the power of a kettle which transfers 20,000 joules of energy in 60 seconds? So power, energy, which is 20,000, and 60 seconds. So I now look at my formula. I go through my equation sheet until I find my formula that has then got power, energy, and time. Power equals energy transferred divided by time. Power watts, energy transferred joules, time seconds. Substitute in my numbers. I'm after the power, so energy transferred is 20,000 divided by the time in seconds is 60 equals 333.3 watts. When a 2,000 kilogram elephant, so we need a mass, okay, we know it's mass because it's in kilograms, so we've got 2,000. Running at 15 meters per second, so that could be a speed or a velocity. What is its total kinetic energy? So that's at 15 meters per second, so we've pulled out our data, now we need to find our equation. Kinetic energy equals half times the mass times speed squared. Okay, now we substitute in. I'm just going to put that as a decimal now. 0.5 times the mass is 2,000 times speed squared, so that is really 15 times 15, or you could just do 15 squared. I'm just going to break it down a little bit. I'm going to do half of 2,000 is 1,000. multiplied by 15 squared is 225. My final answer is 225,000, and because it's kinetic energy, joules. Oops, joules. My J isn't working right there. So I've got an elastic band with a spring constant of 0.8, stretched 15 centimeters. How much elastic potential energy has, right? So what I'm doing here is I'm just thinking, warning, 15 centimeters doesn't sound right. Find my equation. Elastic potential energy, so I'm just writing it as shorthand, you don't, equals half times the spring constant times extension squared. Spring constant, elastic potential energy. Okay, so we've got 0.5 multiplied by our spring constant, which is 0.8, multiplied by our extension, but we've got to convert our extension from centimeters to meters, is then going to be 0.15 squared. So I'm just going to kind of break it up a little bit. Half of 0.8 is 0.4, multiplied by 0.15 times 0.15 is 0.0225, which equals 0.009 joules. Okay, so that's our first one where we've actually had to think a little bit about our units. A block of copper has a mass of, a specific heat capacity, so that's a mass of 3.5, specific heat capacity of 385, and heated up from 26 to 75 degrees C, so that is a temperature change. Calculate the change, triangle means change in thermal energy. So what I do is I go through my equation sheet and I find the correct equation. And my equation is change in thermal, I can't write small, energy, that's in joules, equals mass in kg times specific heat capacity in joules per kilogram degree C multiplied by temperature change degrees C, because it's still temperature, it's just a change of temperature. Substitute in mass 3.5, it's in kilograms, so we go with that. Specific heat capacity is 385 times by temperature change, so we do 75 take away 26 is 49. Then you obviously use a calculator, because you have a calculator in every exam. You will get 66,027.5 joules. A current of 2 amps, so we've got current, 2 amps, flows through a lamp for, so time, 45 seconds. What is our charge flow? Go to your equation sheet and you need to find current, time, charge flow. Scroll, scroll, scroll. I found charge flow in coulombs equals current in amps times by time in seconds. You just got to know your units as well, right? It's dead important. Substitute in, because we're after the charge flow. Current is, 2 amps, multiplied by the time, 45, equals 90 coulombs. Right, so that was then, I think it's about 6 questions there, right? So what you just got to do, you just got to follow that pattern that I showed you right at the very start, learn it, right? Learn the pattern and then you can answer any question. You don't even know and need to know what everything is in it, right? Just learn the pattern, right? And I'm just going to write down pattern here because you need to get it.